How B-2 Spirit stealth bombers are manufactured inside the secret military factory. Most people have seen the B-2 Spirit in photos before. That strange flying wing shape silently cutting through the sky almost does not even look real. It looks more like something designed for a science fiction movie than an actual military aircraft. But what makes the B-2 terrifying is not just the way it looks. It is the fact that this bomber was built to enter some of the most heavily defended airspaces on Earth without being detected until it was already too late. And once you understand how difficult that goal actually is from an engineering perspective, the manufacturing process starts feeling almost unbelievable. Because building a stealth bomber is not like building a normal aircraft where speed and power are the only priorities. Every curve, every surface, every material, every tiny gap between panels can completely affect radar visibility. One small mistake in production could destroy the entire stealth advantage the aircraft depends on. That is why the factory behind the B-2 operates with a level of secrecy and precision most people will probably never fully understand. And the crazy thing is, the B-2 was designed during one of the most tense periods in modern military history, when the United States wanted an aircraft capable of penetrating advanced enemy defenses deep inside hostile territory. Traditional bombers were becoming vulnerable to radar systems and missile technology evolving rapidly around the world. So engineers had to rethink everything from the ground up. Instead of building another giant visible bomber, they created something that almost disappeared into the sky electronically. The result looked unlike anything else flying at the time. No tail, no traditional body shape, just this massive dark wing that seemed to glide silently through the air like it was breaking normal aviation rules. Even today, decades later, the aircraft still looks futuristic because the design was so far ahead of its time. Inside the manufacturing facilities, the process begins with extreme control over materials and measurements because stealth technology is unbelievably sensitive. People often think stealth simply means painting the aircraft black or using some kind of invisible coating. But the reality is far more complicated. Radar systems bounce signals off surfaces, so engineers shape the aircraft carefully to scatter those signals away instead of reflecting them back toward detection systems. That means manufacturing tolerances become insanely strict. Tiny surface imperfections that would barely matter on ordinary aircraft suddenly become major problems on stealth bombers. Workers and engineers inspect sections repeatedly, because even slight inconsistencies could increase radar visibility. And considering each aircraft costs amounts of money that sound almost unreal, mistakes are simply not acceptable. The environment inside the production areas feels completely different from normal industrial factories people imagine. There is no chaotic atmosphere with sparks flying everywhere and machines roaring non-stop like in movies. Instead, many sections feel controlled, quiet, and methodical. Technicians move carefully around enormous aircraft sections while advanced equipment constantly measures alignment and structural precision. Some assembly areas almost resemble laboratories more than manufacturing plants. That is because stealth aircraft production mixes aerospace engineering with material science at an extremely advanced level. Certain coatings and composite materials require highly controlled conditions during installation. Temperature, humidity, contamination levels, everything matters. One error during handling could affect performance later, especially on surfaces designed specifically to reduce radar detection. And then there is the flying wing structure itself, which completely changes how the aircraft gets assembled compared to traditional bombers. Normal aircraft designs rely heavily on fuselage structures and tail sections for stability, but the B-2 depends on its massive wing design for almost everything. That creates enormous engineering challenges, because the aircraft still has to remain stable during long missions while carrying heavy payloads across huge distances. Inside the factory, giant structural sections slowly come together with astonishing precision because maintaining aerodynamic accuracy across such a unique shape is critical. Workers inspect panel fitment constantly since even tiny gaps or irregular edges could negatively affect stealth characteristics. On ordinary aircraft, small cosmetic inconsistencies might barely matter. On the B-2, they become serious concerns. One of the most fascinating parts of the process involves the radar-absorbing materials covering the aircraft. This area remains highly secretive even today because stealth coatings are one of the bomber's most valuable technological advantages. These materials help absorb or reduce radar energy instead of reflecting it back toward enemy systems. But applying those coatings is incredibly difficult and time-consuming. Technicians work carefully across large sections of the aircraft surface, making sure everything remains perfectly smooth and consistent. Any flaws could compromise stealth effectiveness during missions. And unlike normal paint jobs, these coatings require constant maintenance and inspection throughout the aircraft's operational life. The bomber essentially needs to maintain its invisible profile constantly, which means manufacturing standards stay incredibly demanding from beginning to end. Another thing people rarely realize is how much advanced electronics integration happens during assembly. The B-2 is not just a stealth airframe with engines attached. It is packed with highly sophisticated systems handling navigation, targeting, communication, defensive awareness, and mission coordination. And because the aircraft was designed for long-range strategic missions, reliability becomes absolutely critical. Engineers cannot afford major system failures on missions potentially lasting dozens of hours deep inside dangerous airspace. So throughout production, technicians carefully install and test miles of wiring, sensor systems, onboard computers, and communication equipment with obsessive attention to detail. Modern military aircraft are basically flying data centers combined with combat platforms, and the B-2 represented one of the most advanced examples of that concept when it entered service. The engine integration stage is another moment where the aircraft starts looking truly intimidating. Unlike many bombers where engines hang visibly underneath wings, the B-2 hides much of its engine structure within the aircraft design itself to reduce radar and heat signatures. Engineers worked extensively to minimize infrared visibility, because modern defense systems track heat as well as radar reflections. That means engine placement, exhaust management, airflow systems, and thermal reduction technologies all become part of the stealth equation. Watching technicians work around those systems inside the factory gives a sense of just how interconnected every aspect of the bomber really is. Nothing exists independently. Shape affects stealth. Engines affect heat signatures. Surface coatings affect radar reflections. Every system influences another. And then there is the psychological side of the aircraft itself, which honestly might be one of the reasons the B-2 became so iconic worldwide. Even people who know almost nothing about aviation instantly recognize it, because the bomber does not resemble conventional aircraft at all. It looks unnatural in the sky, almost alien. And that visual identity became part of its strategic impact too. The idea of an aircraft capable of flying across continents, avoiding detection, and striking heavily defended targets created an almost mythical reputation around the program. Inside the factory, workers are not just building another airplane. They are building one of the most secretive and technologically intimidating aircraft ever created. And that pressure probably changes the mindset of everyone involved in production. The testing phases after assembly become incredibly intense because stealth bombers cannot simply mostly work. Every system requires extensive verification before the aircraft enters operational service. Structural integrity checks, stealth performance evaluations, electronic systems testing, flight software calibration, engine performance analysis, everything gets examined repeatedly. And unlike ordinary commercial aircraft where comfort and efficiency dominate priorities, the B-2 exists primarily for survivability and mission effectiveness inside hostile environments. So engineers constantly analyze how the bomber performs under conditions designed to simulate real operational stress. That level of scrutiny becomes necessary when the aircraft represents one of the most expensive and strategically important military assets ever built. And honestly, seeing how much effort goes into manufacturing one single B-2 completely changes the way people look at the aircraft afterward. It stops feeling like just another military machine and starts feeling more like the result of decades of advanced engineering obsession. Thousands of specialists, engineers, technicians, and designers contributed to creating something specifically built to challenge the limits of detection technology itself. Every line, every surface, every hidden system inside the aircraft exists for a reason. And the fact that much of its true capability still remains classified even today only adds to the mystery surrounding the bomber. What makes the B-2 manufacturing process even more unbelievable is the amount of secrecy surrounding nearly every stage of development and production. Most factories building civilian aircraft openly showcase assembly lines, engineering breakthroughs, and production methods because publicity helps business. The B-2 program operated in almost the opposite way. Entire sections of the project remained hidden from the public for years, and even many workers involved only handled specific portions without seeing the complete picture. Security inside these facilities became extremely strict because the technologies being developed were considered some of the most valuable military secrets in the world. Imagine going to work every day helping build one of the most advanced bombers ever created while knowing most people outside those walls would never fully understand what was actually happening inside. That atmosphere alone makes the manufacturing process feel different from almost anything else in aerospace history. And then there is the scale of engineering complexity hidden underneath the smooth exterior of the aircraft. From a distance, the B-2 almost looks simple because the design appears so clean and minimal. But underneath those stealth surfaces exists an incredibly dense network of systems working together constantly. Hydraulic systems, fuel management systems, flight control computers, environmental controls, communications equipment, targeting systems, defensive systems, navigation technology. The amount of hardware packed inside the bomber is enormous. And unlike traditional aircraft where pilots physically control many movements directly, the B-2 relies heavily on advanced computer assistance to maintain stable flight because flying wing aircraft behave differently aerodynamically. Engineers had to create software capable of constantly adjusting the aircraft during flight to keep it operating smoothly. So during production, technicians are not simply assembling metal structures. They are integrating an entire ecosystem of highly advanced technologies into one functioning machine. The cockpit manufacturing process alone feels closer to science fiction than traditional aviation. Every display, control interface, communication system, and operational function inside the aircraft gets designed around long-duration missions where crews may remain airborne for extremely long periods under intense pressure. The cockpit has to balance information management with simplicity, because overwhelming pilots with excessive complexity during critical missions could become dangerous. Engineers therefore spent years refining layouts, controls, and onboard systems to ensure crews could operate effectively even during highly stressful conditions. Inside the factory, workers carefully install and calibrate these systems because precision matters enormously. A tiny electronic issue inside an ordinary consumer product might create inconvenience. Inside a strategic stealth bomber, even small malfunctions could have serious consequences during missions. One of the most difficult manufacturing challenges involves maintaining stealth integrity across the entire aircraft surface over time. People sometimes imagine stealth as a single feature added at the end of construction. But stealth is actually integrated into every aspect of the bomber's structure from the beginning. The panel edges, access doors, engine inlets, exhaust systems, and surface materials all contribute to reducing detection risks. Even maintenance crews later have to follow extremely strict procedures because improper repairs or modifications could affect radar signatures. That means the factory process demands extraordinary discipline from the start. Workers are not simply building for appearance or aerodynamics alone. They are protecting the invisible qualities that make the aircraft strategically valuable in the first place. And honestly, one of the most impressive things about the B-2 is the sheer endurance expected from both the aircraft and its crews. These bombers were designed for missions stretching across continents, sometimes requiring aerial refueling multiple times while operating far from home bases. That means reliability during manufacturing becomes absolutely essential. Engineers know the aircraft may eventually operate for dozens of continuous hours under mission conditions where failure is not an option. So every system receives extensive inspection and testing before approval. Wiring gets checked repeatedly. Structural sections undergo analysis under simulated stress conditions. Electronic systems face constant diagnostics. The level of redundancy built into many systems reflects just how important survivability and operational continuity became during the bomber's development. Then there is the aerodynamic testing process, which becomes especially fascinating because the B-2's shape behaves so differently from conventional bombers. The flying wing configuration creates efficiency advantages, but also introduces stability challenges engineers had to solve through advanced flight control systems. During production and testing phases, specialists analyze airflow behavior carefully to ensure the aircraft performs exactly as expected. Tiny changes in shape can influence drag, control characteristics, or stealth performance. So manufacturing precision becomes critical not only for radar reduction, but also for overall flight behavior. Watching massive sections align together inside the factory while engineers monitor exact measurements gives a sense of how unforgiving stealth aircraft production really is. The materials used throughout the bomber add another layer of complexity people rarely think about. Traditional aircraft rely heavily on aluminum structures, but stealth bombers incorporate advanced composite materials extensively because they help reduce weight while supporting stealth requirements. These composites require specialized handling and production techniques different from conventional aerospace manufacturing. Temperature control, curing processes, bonding methods, and contamination prevention all become extremely important. Certain sections may take enormous amounts of time simply because the materials require careful treatment during assembly. That patience becomes part of the process. Engineers are not racing for speed. They are building something expected to perform at the highest level under conditions most aircraft would never experience. One thing that becomes obvious while studying the B-2 production process is how much the bomber represented a technological leap rather than a simple improvement. This was not just a better version of previous bombers. It introduced concepts and manufacturing methods that changed military aviation permanently. The stealth technologies developed for the program influenced future aircraft designs for decades afterward. Even now, many nations continue investing heavily into stealth capabilities because the B-2 proved how strategically important reduced detection could become in modern warfare. And inside the factory, workers were essentially helping create a machine that redefined expectations for what military aircraft could achieve. The first flight testing stages after manufacturing must have felt surreal for everyone involved. Imagine spending years designing and assembling this giant black flying wing surrounded by secrecy, and then finally watching it leave the ground under its own power for the first time. The aircraft almost seems to float unnaturally through the sky because the design looks so different from normal airplanes people are used to seeing. And beyond the visual impact, every successful test represented confirmation that thousands of engineering decisions had worked together correctly. One flaw in systems integration, flight stability, stealth performance, or structural reliability could have created massive problems. That pressure likely hung over every stage of production and testing from beginning to end. And despite all the technology, automation, and advanced engineering involved, the human factor still remained essential throughout the manufacturing process. Skilled technicians, engineers, inspectors, software specialists, material scientists, and assembly teams all played critical roles in bringing the bomber to life. The aircraft represents not just technological achievement, but also coordination between thousands of people working under extraordinary secrecy and pressure. Every completed bomber became the result of countless hours of specialized labor hidden behind closed doors most of the world would never see. That is probably why the B-2 still fascinates people decades later. It is not just because the aircraft looks futuristic or because it carries stealth capabilities, it is because the bomber feels almost mysterious even now. The secrecy surrounding its production, the advanced technologies involved, the unusual design, the enormous cost, the strategic role, all of it combines into something larger than just another military aircraft. And once you understand how difficult manufacturing one actually is, the B-2 stops looking like science fiction and starts looking like one of the most ambitious engineering projects ever attempted in aviation history. If you enjoyed this video, Make sure to like, subscribe, and turn on notifications because there are more insane military engineering stories and secret manufacturing processes coming soon. And some of them are even more unbelievable than this one.